Welcome back. We're still talking about quadratics. We're still talking about the parabolas involved and how to find the important information. As a review, remember the vertex. Once we identify the a, b, and c values, to get the x value, it's the opposite b value divided by 2a. We then take that point, plug it into the equation. We plug and chug to get the y value. Remember the axis of symmetry. Remember, it's written as a line. X equals whatever this value was in the vertex, the x value. Remember, the y-intercept was the c value in a standard form. Just a constant, the number that had nothing to do with any of the other variables. There's two other things we're going to introduce today. First of all, we have to identify if it's going to be a maximum point or a minimum point. Now, this might be the easiest part of looking at a parabola. We know from a parabola, it's either going to open up, like a U, or it's going to be an upside down U. Here's your vertex, so this would be a minimum point. This one would be a maximum point. It only has one or the other, because these lines for this one goes up forever. There is no max, it goes up forever. This one, it goes down forever, so there's no minimum point. Now, how we identify that is the a value. If a is positive, it's going to smile. Okay. This one is if a is negative. This will frown. So again, if you're in a positive mood, usually you're smiling. If you're in a depressed mood, kind of down mood, you're frowning. That's what this will do. The other part of it is the range. Now, we talked about it earlier that the domain of these functions are all real numbers. It goes on forever to the left, on forever to the right. Any x value will be, can be used. But the rate, we do have a range here. Unlike linear functions when the range was also all real numbers, this is not. So we're going to look at our two different functions. The two different possibilities of what our parabolas could look like. If we look at this one, we notice that this has a minimum point. So from this point, all of our values of our y's have to be bigger. They're going up. So we can represent this as y greater than or equal to whatever the y value is of our vertex. Whatever it is, it's got to be greater than that. With this one, again, this is a maximum point. Everything's going to be less than. So we would write this as y less than or equal to whatever our maximum point is, whatever our y value is for our vertex. So those are the two new things we're going to introduce today. Again, if the a is positive, it's going to open up with a minimum value, and our range will be y greater than or equal to. If our a is negative, it's going to produce a parabola that opens down. We'll have a maximum point, and here our y is less than or equal to that point. So we're going to do a couple examples here. Walking through all the different information that we can get out of this. So here's our first problem. Let me tilt it up. We have y equals negative 2x squared plus 8x minus 3. We start by finding our vertex. Our vertex, remember, negative 8 over 2 times negative 2 is negative 4. So it is a 2. We plug it in here. So negative 2 times 2 squared plus 8 times 2 minus 3. When we plug this in our calculator, we get negative 8 plus 8. We get 5. Here's all the information we need. Vertex is 2, 5. Axis of symmetry, remember, it's x equals our x value, so it's 2. Now we come back, maximum or minimum point. The a value is a negative value. So it helps on the side, I'm just going to do a little sketch. I know it's going to be this because it's opening down. This helps me see that I have a maximum point. This will be a maximum point. Our y-intercept is our y value here of -3. And then our range. Remember, we look at the y value of our vertex, which is right here. It's up as high as 5. So our range is y less than or equal to 5. A maximum point will result in a range of y less than or equal to. Over here, we have another problem. Now, I'm going to throw a fraction in here, or a decimal, for our vertex. We start with this as -4 over 2 times 4, which is 8. And we get -1/2. That's the first part, the x value of our vertex. I now plug -1/2 in here. Now when I square it, I end up with, well, we plug it in like this. Let me see, this is going to be a 1 minus 2 minus 5, and we get -6. All the rest of the information is here. Axis of symmetry goes with the x value, so it's x equals -1/2. Again, our a value is a +4, so it's going to open up. This point here is a minimum value. So I know everything's going to be, if we jump down to my range, everything has to be greater than this because this is a minimum. It's going up, and it is -6. It's that value right there. Then our y-intercept again here is -5. So hopefully this kind of clears up, and from this we can answer a lot of questions, answer a lot of problems. See you next time.